record first, then share my screen. Sounds funny. I don't like it. Okay. All right, back to you. Where was our presentation? Actually, we don't have a lot. We still have the few tips. Try this out. You are given some values you're supposed to use. Are you still hearing me? Can you still hear me? Okay. All right, so please use Excel and use your calculator to try this one. I'm gonna try to put the assignment somewhere visible or somewhere for you to put, maybe create an assignment on Blackboard so you put your values and I can assess your work directly, maybe share your the answers with you. Please try Excel and calculator and compare your answers. The question is deduce the resistance of your circuit. So please, you do the decision what to plot, I versus U or U versus X, versus I, and which one is gonna be the slope and how to find the resistance from your slope. Try it, it's super easy. All right, next is this one. What is the slope needed for? If I take in this case, F to be my y-axis and x-axis would be the acceleration. In this case, what would be the slope? What does it represent? Yes, so in this case, M is gonna be the slope. This example, if I take I to be my y-axis and R to be my x-axis, I'm varying the resistance, measuring the I, and U is constant. What do you think my slope will be? Take your time to answer. Yes, I need to know what the slope is. Come on, you guys should know. So I can write it as I to be equal to U over R, right? Or am I wrong? So this is my Y and this is my X. What would be my slope? Yes, 1 over R is my slope. And no, I'm wrong. I'm wrong. This is, no, R is the X. Okay, is it linear? It's not linear. If I plot I versus R, I will get a hyperbola, and talking about the slope will not make sense because this is like U over X. It's like Y is equal to a certain constant divided by X. It's a hyperbola, so we cannot say a slope. What about this one? If I plot T squared versus L, what will be my slope? This is common. You did it last year, spring 2020. Exactly. So if I need to write it down, it's going to be T squared to be equal to 4 pi squared, and never forget the pi squared because I do, divided by G multiplied by L because the square root is over. If I'm going to take this to be my X and this to be my Y, this would be the slope, the remaining slope. Okay. So if you know, if you find the slope, you can deduce G. And if you find the error on the slope, you can find the error on G as well. It will be a little bit time consuming, but at least you will know it's not wrong. Okay, how about this one? Yes. No, you need to do propagation of error. Propagation of error, like we had the error on G and the error on alpha, and we found, deduced the error on the acceleration. Here you would say slope is 4 pi squared over G, and then calculate doing the derivative to find the error on G. If you want, we can have a session about it later on. But it's no big deal since we will not have this example in Physics 306. We will have maybe easier or more difficult examples. We can try on those as well. Now I'm on item 5. If we go back to my content, we did item 1, 2, 3, and 4. What is the slope needed for? And now let's try to find the error on the slope. You already know how to do this, but it was maybe somehow difficult for you. Let's discuss what it means. You see a total cost versus the number of games rented. You see the error is very small. the points are basically on the line. Maybe there's no error at all. Sounds like super linear. This one, you see is that the points are spread, or you can see some fluctuation around the straight line. In this case, can you tell me in which case you have more error? Yes, you can see that the measurements are spread, and you can see the error or the fluctuation along the blue line is much greater than the fluctuation you have in example 2. So the error is related to how far away the points are to the line. Here they show you that the most important, yes. No, they don't cancel each other because you need to do the sum of the squared, but you will end up with the same line. So what I was trying to say, if you have a big spreading or less spreading, maybe the average line would end up being the same because somehow they cancel each other. But I was wrong to use a very easy statement of canceling each other because it's misleading. And your question is very legit, because I was gonna show you that no, they don't cancel. What we care about is the vertical distance and not the horizontal distance. So we're gonna take every point and find the vertical distance away to the line, square each, let's call it deviation, square each, and then add them up. This reminds me very well of the first slide. Do we still have it open? The first set of slide, is this it? Yes, this is it. So do you remember when I showed you this equation, and I like it so much? Do you see DI? DI is the deviation, and the deviation represents how far away each length is from the average. You see? So now I'm gonna do exactly the same thing. I'm gonna call it deviation. It's gonna be the vertical deviation. Okay, so how can I do it? I think the only way to be able to do that is to do it by calculation. We cannot do that using Excel. I'm gonna use Excel though just to do a simple calculations, and let me show you. Okay, this video was error on the slope. Okay, so
hello everyone, one of your friends asked me.
So this video was taken spring 2020 for physics 302 students, and my voice was low because it was really in the middle of the night. So, and I'm showing you how I'll be doing the calculation. Let me explain a little bit. So the error on the slope is called alpha B, B being the slope. And I'll be calculating alpha squared and then square rooting the answer. And I'm going to show you how to find the slope. This is already done, slope and y-intercept, because I need them. The slope is B and the y-intercept is A. I will show you how I'm going to calculate each deviation alone, then square each, then add them up and fill in the equation. So your job, this is the equation of the error on the slope. I'm just explaining what each term represents and how to calculate it quickly using an Excel spreadsheet, because you don't want to find E1 by hand, E2 by hand. This will take you forever. Okay, so let's do it.
Concerning the error on the slope. So I prepared this for you. So how do we calculate the error on the slope? First of all, you need to make sure that you have a list of data to present X first, then Y first. By the way, I did all the calculations here on Excel, but you can easily do those calculations on a paper. But Excel is much faster. So, and then you plot by selecting X and Y. This is the plot I had. You right click on the values and you create a trend line. You add equation. The equation is beneficial because it could give me the slope B and the y-intercept A. I've written the y-intercept and the slope in this box. N is equal to 11 is the number of trials or the number of measurements or the number of points on the graph. So I need to find the error on the slope, which is given by this equation. I need n, and n is given by this value. I also need delta. What is delta? Delta is n into sigma xi squared minus sigma xi all of it squared. So to be able to do this, I need to add the x's together, and I already did. So this is sigma x. And then I squared this box. So if I click on this one, you see the formula. It's F34 times F34, or in other words, F34 squared. So you can see it. Okay, so this is sigma xi squared. Concerning xi squared, sigma xi squared, like this one, I had to square each x in this box. I drag, and then I find the sum. So to be able to find delta, if I click on this one, you see the formula. It's C22 times J38 minus F37, which means it's N times this guy minus this guy. Okay, and it gave me this equation. I'm done with delta. Now I need to find E. E by definition is BXI plus A minus.
Are you aware of the fact that E is the, you see, it's the Y, meaning the straight line, minus YI, meaning the point. So this is the vertical deviation, the difference between the straight line and the point. The straight line is BXI plus A, B and A are constant. It's only that X that is variable minus YI. So you can find E for each set of values and then square each, then add them up.
Y. So if you click on E, you see it is the slope times the x minus the y-intercept, no, plus the y-intercept minus y. So b times x1 plus a minus y1. This is E1. And then I drag for all of these. Then I square each. Then I add them up. So this is the sum of all these. This is sigma ai squared. So I have sigma ai squared, I just plug in the values. So for me to find the error on the slope, I do 11 over 9, which is n over n minus 2, then multiply by sigma ai squared, then divide by delta. This is not really the error on the slope. If you really think about it, this is actually the error on the slope squared. So don't forget the squared, which means you have to square root this value, and whatever answer you get, don't forget to actually, yeah. Okay, so yeah, how can I remove? Okay, I want to remove the eraser. Okay, so back to this one. When you're done with doing the square root of this value, don't forget to round to one significant figure, and don't forget to add a unit, and don't forget to round the slope accordingly. Okay, so the slope. If you have any other question, let me know. Thank you.
All right, so I think we're done. The last slide is for you to try this again. Now you already did the y-intercept and the slope. Your job is to find the error on the slope. All right, so you see the example is easy and it's not meant to take you some time. It's only to simple application for you to make sure that you got the idea. So we can
Yeah,
be
you
ready.
want it. Yeah, Excel, right?
Say it again. You will, so the first example you have to do via Excel and calculator. The second one, to find the error on the slope, you have no choice. It's a simple calculation via Excel, on a paper, it's up to you. So I'm not using Excel, I'm using an Excel spreadsheet to help me with the calculations, but I'm doing simple calculations. Like, I mean, there's no function on Excel that would give me the error on the slope directly. By the way, there is a function on Excel, but it's not straightforward to use. Okay, and since we may not have Excel in our midterm, why learn to use the function? It's like a big function over a table, while it's equally time consuming as the one that I showed you in the video. All right, you guys, so you will have two recorded of this session, but you don't really need the recording since you have the slides and the two videos and the assignments on the slides. If I were you, I start with the assignment until I show you where to post it. Concerning, yeah, a quick note concerning, and thank you, Maria, Michelle, for the reminder. I need a file to write on. Yes. A quick note concerning the difference between precision and accuracy. Last week we discussed the difference in meaning, but we didn't have the chance to show you how to calculate the difference between precision and accuracy. Yes. So it's only this app that is taking me time to open when I'm recording. All right. So there's something called the percentage difference. Maybe let me type it down. I would call it percentage difference. Does it have percentage difference? Some people call it percentage error. Okay, but percentage difference is more meaningful. How do you calculate this one? Yeah? Okay, so for me, you find the difference between the values. The values is the theoretical versus experimental, or you can say nominal versus experimental, or the one you were expecting versus what you got. So the difference, and usually we take the absolute value because we don't care about negative or positive, bigger or smaller, and you divide by the reference. I'm gonna call it reference. Usually the reference is the theoretical. In physics lab, it's usually the case. And eventually you multiply by 100 to make it a percentage. Okay? This is the percentage difference. If this is less than 5%, you can say it is accurate. And it makes sense because if there's a huge difference between what happened in reality and what's happening in theory, then it's not accurate. But how can I prove precision? So precision for me, how do I find it out? I'm not supposed to find the difference. I'm supposed to look at the uncertainty. Okay, like sometimes uncertainty. Sometimes you say F is equal to 2.00 plus or minus, yeah, 0.01 newtons. Is this precise or not? The only way to check precise or not, we don't look at the real value of it, real being the reference. We look at the error. This error, is it big or small? And to be able to say big or small, we should compare it with this one. So I'm supposed to take 0.01 and divide it by 2.00 and to be able to compare them, like find the ratio. Okay? Multiply by 100 to make it a percentage. Okay? So for us to be able to do so, what we usually do is the following. We take the error, or some people call it uncertainty, divide by the measurement, okay? And eventually multiply by 100. And let me just, I don't want to be misleading, okay? Yes. If this is less than 2%, we say it is precise. So the measurement is precise. We say the measurement is precise. Okay, so to discuss accuracy, we actually follow the percentage difference. Okay, and to be able to discuss precision, we follow something else. Less than 2% is considered to be precise if this ratio is less than 2%. And again, this ratio is different than this ratio. This comparing the uncertainty as a function, comparing the uncertainty towards the measurement, here comparing the difference between something measured and a reference. So the ideas are basically different. Is that it, Michelle? This is what was confusing you? Yeah, this is very important to keep, but I can remind you about this one anytime. So if they ever ask you in any lab report, discuss accuracy and precision, please don't say accurate. Give a reason why it's accurate. Don't say precise. Give a reason why for things to be precise. Try not to be qualitative in your lab reports. Don't describe things. Try to be quantitative. Don't say proportional. Find a constant ratio. And same for precise and accurate. Try not to compare by saying bigger or smaller. Say it's 5% different, 5% bigger, you know? Try to be quantitative. But again, I will remind you for every session. That's it for today. Next time I see you, we have a live session. I will have to introduce the first experiment and explain how we will be doing your lab reports. Okay? Yes, Michelle. This is not the percentage difference. This is concerning precision. So the two ideas are separate. Yes. Yeah. Yes. In this case, it has to be one significant figure, because you're dividing one significant and three significant. The answer is like the least number of significant figure. So yes, it's one significant figure. And this may affect your result, لأنه you want it to be less than 2%. إذا طلعت 1.6 تكبر كتير. Yeah, yeah. Good questions, Michelle. Please ask anything you want and don't consider that everybody else knows the answer, because trust me, most of these questions have open-ended answers somehow. We're discussing statistics and this is a very big topic, and the application on physics labs. So not all the answers have very direct, all the questions have very direct answers. So please do ask. I'm done. So you are free to leave and I'll see you next Monday. You too, enjoy your day. Bye.